Okay, so what we're looking at here today is we're looking at solving equations algebraically. And we're only looking at really simple ones. So I'm just going to write a few up. So let's just say I've got 6m equals 36. And then I've got 7 plus t equals 21. And then let's just say I've also got, let's do one with division. So let's go 20 divided by x equals 4, okay? So I've got three really simple equations. And when I look at these equations, I know that everyone here could actually solve these by using inspection. So remembering inspection is just when you look at it and you go, well, 7 plus something equals 21. So what is that something? And you can figure it out in your head. But what we need to work out is we need to start to understand how to solve these algebraically, because soon you will get equations that you're not able to solve by inspection. So we're going to go through the working out process for these. And when we look at it, we've got two sides. We've talked about having two sides to an equation. We've got the left-hand side and the right-hand side. And what we want to do is we want to collect our like terms. Now, firstly, there are no like terms here to collect. If there's brackets, we want to expand. So we want to expand when we can. We want to collect our like terms, and then we want to isolate. Now, when we isolate, what that means is we want to make the variable be on one side of the equation all by itself. Okay, so if we have a look at this one, I want you to think about it, and I want you to try to identify the variable in this equation, and in this equation. Just have a think about it. What are the variables? So obviously the variables are the letters. Okay, they're our letters. So on one side of the equation, we want the letter to be by itself, the variable, and then obviously a constant term on the other side. And the way that we do that is we need to start thinking about order of operations, and we need to think about what operation is actually in this equation. So if we look at 6m, I'm just going to write down here, 6m. What does 6m actually mean? Well, m is our variable, okay, and 6 is the coefficient. So what that actually means is 6 times m. So in this equation, we have a multiplication operation. Here, we obviously have an addition operation. And over here, we've got our vinculum, and a vinculum is division, okay? So we've got multiplication, addition, and division, okay? So what we look at is we want to do the reverse of multiplication, okay? And the reverse of multiplication is division. So what we're going to do in order to get rid of this 6, if I'm multiplying something by 6, in order to cancel that out, so it's no longer there, I do the exact opposite. So I divide by 6, okay? And I'm going to get rid of this 6. I'm going to divide by 6. But whatever I do to one side of my equation, I have to do to the other side. So on this side, I'm also going to divide by 6, okay? And then we get a situation where we have a new line of working, and 6 divided by 6 cancels out that 6 for me. So I've isolated my variable and I'm just left with an m. But over here I do 36 divided by 6, which gives me 6. So all of a sudden I've isolated my variable to the left-hand side, and I've got my constant term on the right-hand side. If we look at this one here, 7 plus t, the opposite operation of addition is subtraction, okay? So I want to take away 7 from this side, the left-hand side of my equation. But whatever I do to the left-hand side, I also have to do the right-hand side, okay? So 21, take away 7, gives me 14. Now, I'm sure that you're sitting there and you're thinking, well, I know how to do this. I was just doing it by inspection, just by looking at it. But it's important that we understand this process of working our way down the page. So if I look at this one over here, I've got 20 divided by x equals 4, and this one's actually going to be a couple of steps. We're going to find that our variable x ends up on the right-hand side. So remember, we've got left-hand side and right-hand side. So in order to get rid of divided by x, I need to multiply by x, okay? So I'm going to times both sides by x, okay? So that means that this x disappears and I'm left with 20 on this side, and I'm going to multiply 4 by x. So 4 times x gives me 4x, all right? Now I need to do another step. And in this step, I'm going to look at this one here, and I need to get rid of that times 4. And in order to get rid of times by 4, I divide by 4, okay? So when I divide by 4, I get rid of the x, okay? And 20 divided by 4 is 5. Now, I'm sure that you would have looked at the initial question up here and you went, well, 20 divided by something equals 4. The answer is going to be 5. But if you actually have a look at how we stepped out the working there, okay, it'll give you a better picture of what you need to do in the future. The only thing that I will say about this one is that you'll notice that when we finish, our variable ends up on the right-hand side. Generally speaking, we prefer it if you put your variable on the left-hand side and then your constant term on the right-hand side. This is obviously still correct, but if you can display your final answer like that, then mathematically we're working well.